Hey there, fellow code wizards and algorithm aficionados. It's Steve here. Let's talk about a revolution brewing in our world, quantum computing. Imagine a world where our trusty bits, those zeros and ones we know and love, are replaced by something far more slippery, qubits. These quantum critters can be both 0 and 1 at the same time, thanks to the wonders of superposition. This mind-boggling ability opens up a whole new dimension of computational power. We're talking about solving problems that would take classical computers longer than the age of the universe, and doing it before your next coffee break. And that's where we, the intrepid software developers, come in. What you need is a shift in perspective, a willingness to embrace the weird and wonderful world of quantum mechanics. Remember all those elegant algorithms and data structures you spent countless nights mastering? Well, get ready to reevaluate them through a quantum lens. Quantum computing isn't just about faster hardware. It's about a fundamental shift in how we think about computation itself. In the quantum realm, we have to embrace uncertainty. We can't know the exact state of a qubit, only the probability of it being a 0 or a 1. This inherent randomness opens up a whole new world of possibilities for probabilistic algorithms and simulations. Imagine simulating complex molecules to design life-saving drugs or optimizing financial models with unprecedented accuracy. Just like we don't need a supercomputer to write a simple Python script, we can start experimenting with quantum concepts in our current software development practices. So how do we bridge the gap between the theoretical and the practical? That's exactly what we'll explore in the next part of our journey. All right, let's get down to brass tacks. We've established that quantum computers are different beasts altogether. One approach is to use what we call quantum-inspired algorithms. These bad boys take inspiration from the principles of quantum mechanics, but guess what? They run on our good old classical computers. Think of it like this: you wouldn't use a jackhammer to crack a walnut, right? Similarly, some problems that seem daunting for classical computers can be tackled with surprising efficiency using these quantum-inspired techniques. One prime example is quantum annealing. This makes it incredibly powerful for optimization problems, like finding the most efficient route for delivery trucks or optimizing financial portfolios. These quantum-inspired algorithms aren't a magic bullet, but they do offer a fresh perspective and can lead to significant speed-ups for certain types of problems. The good news is there are already libraries and frameworks popping up that make it easier to experiment with these algorithms. So, embrace the superposition, my friends, and get ready to explore the possibilities of quantum-inspired algorithms. Now, let's talk about another mind-bending quantum phenomenon that has the potential to revolutionize how we think about data entanglement. Imagine two variables so deeply connected that changing one instantly affects the other, no matter how far apart they are. In the quantum world, entangled qubits share a special bond. This interconnectedness allows for incredibly efficient information processing and communication, making our current data structures look like clunky relics of the past. Think about it. Our current databases store information in individual bits, like storing ingredients for a recipe in separate containers. But entanglement is like having those ingredients magically combined in countless ways, ready to be accessed instantly. Researchers are already developing new ways to represent and manipulate data based on these principles. Remember that bumpy landscape we talked about earlier? Well, optimization problems are everywhere in software development. From finding the shortest route for a ride-sharing app to optimizing the performance of a complex machine learning model, we're always on the lookout for the best solution in a sea of possibilities. Quantum algorithms, with their ability to explore multiple possibilities simultaneously, are uniquely suited for tackling these optimization challenges. One promising area is quantum-assisted optimization, where classical algorithms team up with quantum computers to solve complex problems. The classical algorithm handles the heavy lifting, while the quantum computer swoops in to solve specific sub-problems that would bring a classical machine to its knees. From logistics and finance to drug discovery and materials science, industries are already starting to reap the benefits of this powerful synergy. Hold on to your hats, folks, because we're diving into the world of quantum logistics. Picture this. Instead of those frustrating delivery delays and traffic snarls, we have fleets of trucks and drones navigating cities with unparalleled efficiency, all thanks to the power of quantum optimization. Remember the traveling salesperson problem? That classic brain teaser where you have to find the shortest route to visit multiple cities? It turns out that quantum computers are particularly adept at solving these kinds of optimization puzzles. Companies like Volkswagen are already experimenting with quantum algorithms to manage traffic flow in cities, optimizing routes for buses and taxis in real time. Quantum logistics can also optimize supply chains, reduce fuel consumption, and minimize delivery costs. We're talking about a future where packages arrive on time, every time, and the environmental impact of transportation is drastically reduced. While large-scale quantum logistics is still in its early stages, companies like D-Wave and IBM are already offering quantum-inspired optimization services that are being used by businesses around the world. Now let's talk about a topic near and dear to all our hearts, money. More specifically, how quantum computing is poised to revolutionize the world of finance. Quantum algorithms, with their ability to analyze vast data sets and perform complex calculations at warp speed, are uniquely suited for tackling the challenges of the financial world. They can sift through mountains of financial data, uncovering hidden patterns and correlations that would escape even the most sophisticated classical algorithms. Quantum finance can also be used to assess risk more accurately, develop more resilient financial systems, and even create new types of financial instruments that were previously unimaginable. We're talking about a future where financial markets are more efficient, transparent, and accessible to everyone. Now let's shift gears from the fast-paced world of finance to something even more impactful, healthcare. Specifically, how quantum computing is poised to revolutionize the way we discover and develop new drugs. Imagine a world where we could design personalized medicine tailored to your unique genetic makeup, simulate the effects of new drugs with unprecedented accuracy, and develop new treatments for diseases that were once considered incurable. One of the biggest challenges in drug discovery is understanding how molecules interact with each other. Quantum computers excel at simulating quantum phenomena. It's like having a virtual laboratory where you can experiment with different drug candidates without the need for expensive and time-consuming physical experiments. We're talking about a future where new drugs are developed at warp speed, bringing hope to patients suffering from diseases like cancer, Alzheimer's, and HIV. So, we've explored the mind-bending world of quantum computing and its potential to revolutionize everything, from logistics to finance to healthcare. The rise of quantum computing doesn't spell the end of software engineering. It heralds the dawn of a new era. Just like the advent of the internet or mobile devices created entirely new industries and job markets, quantum computing will give rise to a new breed of software developers, the quantum software engineer. These quantum code wizards will be the architects of the future, building the software that will harness the power of these quantum behemoths. So, if you're a software developer who loves a good challenge, who's always eager to learn new things, and who's not afraid to embrace the weird and wonderful world of quantum mechanics, then the future is yours for the taking. The quantum-powered future challenges and opportunities. The quantum revolution is upon us, and it's bringing with it a tidal wave of challenges and opportunities. It's a time of great upheaval, but also a time of immense potential. As software developers, we have a front row seat to this technological tsunami, and it's up to us to ride the wave or get swept away. One of the biggest challenges we face is the sheer complexity of quantum computing. Understanding how qubits interact, how entanglement works, and how to design algorithms that exploit these quantum phenomena requires a significant investment of time and effort. It's not something you can pick up overnight by watching a few YouTube tutorials, though this one's a good start, but the rewards for those who persevere are immense. Quantum computing has the potential to solve some of the world's most pressing problems, from climate change and disease to energy scarcity and cybersecurity. Imagine developing software that can design new materials for renewable energy, simulate the effects of climate change with unprecedented accuracy, or break the encryption codes that protect our most sensitive data. These are just a few examples of the transformative power of quantum computing. However, with great power comes great responsibility. As we develop more powerful quantum computers, we need to be mindful of the ethical implications. What happens when these machines fall into the wrong hands? How do we prevent them from being used for malicious purposes? These are questions we need to start grappling with today before it's too late. Beyond the hype, a realistic timeline for quantum domination. Now, let's be realistic for a moment. Despite all the hype surrounding quantum computing, we're still in the early stages of this technological revolution. Building large-scale, fault-tolerant quantum computers is a monumental task, fraught with technical challenges and unforeseen obstacles. It's like trying to build a spaceship out of toothpicks and chewing gum. It's theoretically possible, but it's going to take some time. So, when can we expect to see quantum computers solving real-world problems on a daily basis? The honest answer is, it depends. Some experts predict that we'll achieve quantum supremacy, the point at which quantum computers can outperform classical computers for certain tasks within the next decade. Others believe it will take longer, perhaps several decades or even more. But here's the thing, we don't need to wait for quantum computers to be perfect before we start benefiting from them. Just like we don't need a supercomputer to write a simple Python script, we can start experimenting with quantum concepts in our current software development practices. We can learn the basics of quantum algorithms, explore quantum-inspired optimization techniques, and start thinking about how to design software that's quantum ready. The quantum revolution is not a single event, but a gradual evolution. It's a journey, not a destination. And as with any journey, the most important thing is to start walking. So, embrace the uncertainty, my friends, and get ready for a wild ride. The Quantum Horizon, a call to adventure. As we stand on the precipice of this quantum revolution, gazing out at the uncharted territories of possibility, one thing is clear. The future of software development is about to get a whole lot more interesting. It's a time of immense potential, but also a time for bold exploration, for challenging our assumptions about what's possible with code. It's a call to adventure for all you code warriors, a chance to be pioneers in a field that's still in its infancy. Remember those early days of the internet, when a bunch of geeks in their garages were building the websites and apps that would eventually connect billions of people around the world? That's where we are today with quantum computing. It's a wild west of innovation, where the rules are still being written, and the only limit is our imagination. So, what are you waiting for? Dive into the world of quantum computing. Learn the basics of qubits and entanglement. Experiment with quantum-inspired algorithms. Start thinking about how you can apply these concepts to your own work. You don't need to become a quantum physicist overnight, though it wouldn't hurt, but you do need to be curious, adaptable, and willing to embrace the unknown. Our quantum future. A symphony of bits and qubits. The future of software development isn't about replacing bits with qubits. It's about creating a symphony of both, building hybrid systems that leverage quantum power for specific tasks while relying on classical reliability. Imagine your smartphone connecting to a quantum cloud, offloading complex computations, or your car, powered by quantum computing, optimizing fuel efficiency and navigating traffic. This quantum-powered future is within our reach, but it won't happen overnight. It requires effort from researchers, developers, and policymakers. The quantum revolution is about building a better future for all. Let's unleash the power of quantum computing and create a bright, awe-inspiring future. If you enjoyed this video, don't forget to like, share, and subscribe for more content on the future of technology.